Hello.
Hi.
We are we're running into a technical issue with captioning, and we don't want to say or do anything important without captioning available. So we're going to stall and make dumb jokes or something until our captioner is able to get on stream.
Yeah, we want to make sure nobody misses any Bang Bang content. So you've got us for the next few minutes.
Alicia, why don't you stall for a moment while I type something?
Perfect. Yeah. So I have some good news to share with everyone. My cat DC has been missing since Monday, and he stormed into our house yesterday at around 3 a.m. Here he is, sleeping in his box, very happily. He just came in, started meowing, got his tuna, walked around the house, sniffed everything, found his box, and that's where he's been since. So, yay! We're very happy, very tired. Hopefully he will not wander off again. So I will be awful right now, and I'll pick him up to give you some premium cat content and not just like black shape in a box. Come on. Oh, yes. He's very sleepy and very unhappy. You can see his beautiful white belly. So when we were searching for him, we put posters everywhere, and it turns out there's a lot of tuxedo black and white kitties living here. So we were running around for the full week, responding to every call. I met a lot of cats and made a lot of friends. So yeah, you can share your feelings with DC about him being lost for nearly a week. He's very unhappy right now. Yes. Okay, that's my premium cat content for today. How about you, Artie?
Oh my gosh. I don't have premium cat content. I'm sorry. Actually, we do have a cat, and I don't know where she is. Not in the like scary way, just in the like probably hiding in the basement or something right now. However, I did reformat my computer and reinstall Windows today, which was very exciting. I'm missing. So my as you all noticed, my computer was crashing yesterday during the stream. It's been crashing for a while. I thought it was electrical issues, but we actually had electricians come and replace basically all of the wiring in our house last week. So it's still crashing, so it's not electrical issues. Anyway, I'm missing like half my drivers, but you can't have a driver cause a blue screen if you don't have drivers installed. So that's success, I think. Yeah, it's like taken apart right now. I can show you my little
yeah.
This is my my little cube computer. I have the front off right now. It has this massive fan because it's basically a tiny jet engine, and you can see my graphics card doesn't quite fit into the case also. So
was it overheating yesterday too? I think you were saying that.
Well, I was worried it was overheating, but I actually don't think that. I was watching the temperatures, and it was at like 30 degrees Celsius when it shut off. So I don't think that's the case. All right, we are continuing to delay. Yes, please, Cindy, if any other organizers are here and want to banter with us.
Oh, no, here I am. Hello.
Hi.
While we wait for our captioning.
You can tell that I had not planned to be on camera today. I just got off my bike. And I'm in a, one of the wonderful things about YouTube is that it's not a smellophone. And so I guess that's not as bad as it could be.
I also was not planning to be on camera. Neither was Theodosius. And yeah, that's fine. We'll figure it out. This is premium cat content. Look at this.
I was going to say that, this is really, I didn't see DC yet. I didn't join the stream yet. Is DC still around? Is that DC in the corner?
He's right here, coming back to his box. He's very annoyed with me.
Oh, fantastic. On my way home, I was out riding, and I have like a circuit around my neighborhood of the neighborhood cats. And there's Cindy. I'm not sure that was intentional. Is
Nope,
it?
that was. I asked.
There we
Sorry.
Okay. All right.
I figured people could
My other
see
cat.
the auto
Okay.
I have 2 giant cats. And it's very rare, but I have them both on screen right now.
We're having technical difficulties. That is correct.
Yeah,
Um,
only cat content for now.
I also discovered today, after however many years of being a Windows user, the Windows key and period opens an emoji picker.
Really?
Apparently, I was not the only one.
Yeah, I use it all the time. It's great.
I usually use it's like like Command Shift. No,
Yeah.
what's it on a Mac?
Control Option Space?
Control Option Space on a Mac. I think.
No,
does
Control Command Space, I think.
Control Command Space. That yes.
Yes, Control Command Space. Just check.
And there's not one on Linux, and it drives me bonkers because I don't know how to. I can't easily pick.
There's a various compose key things that you can do. Like I'm used to OS 10 hitting Option and mashing stuff, although I don't know how to emojify on OS 10. But I think you can get various emoji on Linux with the compose key, like compose : smile. Oh no, that's not it.
What is the compose key?
Oh, you were in for a treat. So the compose key on some keyboards, on my keyboard, it is right alt.
Okay.
And so if I press right alt, then apostrophe, then E, I think that's right. Yeah, right. Then I get E accent. And so it's similar to if you had held Option and hit apostrophe, then hit E, or no, hit Option E, I think, on OS 10.
Mm.
Yeah, that's compose key is used in the non-English languages because we need some diacritical marks. So like when you write Polish, you use it like half the time, though it's usually
I was going to say like
control.
80% of the characters in Polish involve a compose key.
Yeah, a lot of them, and most of them in consonants. So yeah.
Oh, look at that! I did a locate compose, and I have user share x11 xkb symbols compose. I think that's. Oh, look at that!
Can you define your own composes? Is this?
Oh yeah, you totally can.
Okay.
You totally can.
All right, cool. That's very Linux.
Yeah. Or user share x11 locale compose.dir.
So just to let everybody know, and actually let me just add this to my little slide over here. We are going to stall until 8:10 Eastern, 10 after the hour.
I'm trying to get all over any way I know possible.
And move forward without captioning if we still don't have it. Captioning, I'll make this text bigger in just a moment. Captioning will be, you can tell I don't type as fast as our captioners. Captioning will be available on the rebroadcast, sync watch, and also on the recording. So if we don't hear back, and I'm trying to make this available as text. If we don't get captioning set up in the next 2 minutes, we will move forward. We'll have our speakers present without captioning, and then we'll just add those captions later. And just with our sincere apologies to anyone who's deaf or hard of hearing.
Or who uses captions otherwise.
Or who uses captions otherwise. Thank you so much, Joshua. For anyone who uses captions for any reason, I will put up a little we are very sorry slide, and then we will move forward with the rest of the thing in about 60 seconds. But let's us all try one more time to get the caption thing working. I used to know this joke about Java, but I was trying to find it on the internet, and one, I couldn't find it, and two, I couldn't remember if it was appropriate to share it with Bang Bang Con. So maybe it's better that I couldn't find it. So that's why I didn't immediately launch into the. I was promising the other organizers that I had more jokes lined up, but it was a lie because I was just hoping I could find it on the internet before I actually had to present it, and that didn't happen.
You know, we can always make impromptu musical breaks or
Oh yeah,
something. You know, we have some people with instruments. We
there
can
you go. All right, it is
You
10
have
after
some
the hour.
instruments.
It is 10 after the hour. So I'm going to pop up a thing that says, "We are so sorry." You can tell that I am not a captioner. We are so sorry, but we are going to move forward without captioning for the live part of, for the live version of this event. We will provide captions for the rebroadcast. And
I guess I better tweet to that effect too, huh?
Yeah, and let's announce it in Discord as well.
Yes.
Yeah,
So all of you who are on the stream who are watching live, this is how Bang Bang Con works. Like usually all of these things happen approximately 10 minutes before we start the show, or when the show starts slightly late. This is usually what is happening, and you don't get to see it, but you are getting a very special window into Bang Bang Con this evening, right here live on YouTube, as you watch as this occurs. So welcome to Bang Bang Con. Welcome to the inside of Bang Bang Con. The idiom in English is how the sausage is made. Is there a? I always think I always like Polish idioms better. I always think that Polish idioms are like more evocative. Is there a Polish idiom to that effect, Alicia?
Oh, you know, you're asking me out of the blue when I'm in English mode. I will have to get back to you on that. I promise I'll follow up on that during one of the breaks between the talk, because I just can't remember off the top of my head. But there's definitely something.
Maybe there's like an interesting etymological, like in English, it's how the sausage gets made, you know, and then in other languages, maybe it's different how the some other thing gets made.
That's right.
That like the directed graph of "It's all Greek to me."
Yes, that's right. That's right. That's right.
And then if somebody can find that, drop it in Discord. All right, let's get started for real. Hello, welcome to session number 3 of Bang Bang Con 2021. We're very excited to have everyone here for our upcoming 4 talks, and I am going to look what they are right now. All right. So we have stalled enough, and we will get right into our first talk by Andrew Stillers, titled Night of the Living GIF, or GIF, Making Interactive Multiplayer Experiences on a Static Web Page.
Living GIF. Let's jump right in. So I'm going to talk about HTML. HTML, you probably know, is the stuff that websites are made of. You've got your image tags where you're saying, hey, here's a URL, render this image. Hey, here's a link. When you click on that, go to this link. What you probably didn't know is this could be the client-side code of a real-time multiplayer game. So I'm going to talk about how we build that. So in the usual case, we have an image tag. It's going to send this request. So it's for bts.png. This sends a GET request. This actually literally are the characters that come down the wire. There's a bunch of other stuff too, but and then the server responds and says, okay. And then it sends a picture of BTS. What you might not wonder about, then it renders it. The final step is the browser gets this, renders it. So what you might not wonder is where this came from. So maybe it came out of a file system. That's pretty likely, but it doesn't have to be. It could have been generated by random bits. Maybe it was just making a bunch of random pixels, and this happened to be the one time that it made a K-pop group. Or more likely, maybe there was something else, like there was a neural net that was trying to make the coolest image possible. And the important thing is this could vary. You could send, this request for bts.png later, and it could come back with something different. Maybe the neural net has been churning for a long time, and it comes up with a cooler picture of BTS. But the point is, this is reflective of some kind of server-side state. So we can make a game. We can make a real simple game where we ask for the show image from a server. So we say, hey, server, show me. And the server says, okay, I've got a hero who's at coordinate 1, 0. So I'm going to render the hero at those coordinates. And then we we render that. So we see this black dot, that's the hero. You can also alter state with requests. So suppose we have a link. User clicks the link that says go down. And the server sees this and says, I know whenever I see a go down, I will move the hero's position and I will change y+1. And then I will do something very special where I will not respond with something. So previously, I showed like it sends back an image. It's going to send back not a 200 response, but a 302 response, which says, I don't have anything to give you. Go here. So just go somewhere else. So this means that we can send a user who clicks a link anywhere on the internet if we control this server that they click the link to, or anywhere on the web. So post redirect, let's say we send them back to this thing I just showed you where it's like show, and now the hero is at different coordinates because we just altered the state when they click the link, and now they're back at this page with the IMG tag, and boom, we've rendered a different image. So we have changed the game state, they're playing a game, they're moving this black dot around. All right, so now I'm gonna show you an actual application. So suppose we have, okay, archive of our own, it's a site for, I actually have a tab still open, but so it's a site for posting fan fiction. But we're gonna look for Colossal Cave fanfic, and we're gonna come up with the thing that I made, Colossal Cave Adventure. So this actually is the Colossal Cave Adventure, if it's going to render today. Oh, yep, here it is. Ta-da, this is Adventure. So this is a text adventure that we're playing right now. And we can say like, we're outside of a dirt building. Okay, we're gonna go in. And now we're inside the building. Ta-da, we're playing a game. So the cool thing is this isn't actually text. This is actually an image that I've just written text onto. So you can see this is a 500 by 400 image that's sent from the server. And I can say like take, and it has a little buffer of the command that I'm writing, and it knows take isn't a complete command. So it's waiting for me. What do I want to take? I'm going to take this food. And so now I'm holding this food. And you can see this image is now different. This is what it was previously. After I clicked those links, this is what the image that came back from the server. So ta-da, we're playing Colossal Cave Adventure. All right. So this is pretty cool. Because we can send any signal to the server using A-links, and we can bounce them back to the game, because that's what was happening. I was clicking this link, and it was going away to the server that has my adventure game state, and then it's bouncing them back to AO3. So we can render any server state using an IMG tag. So that can be anything. Anything that is expressible via an image, we can make it. Sounds like we can do anything. But wait. I did promise that we were going to do real-time games, and IMG can only render state information one time, and it's done, right? So we need to refresh the page to get an updated state. For a text adventure, that's fine because we're just lobbing commands at it, and then it says, okay, well, here's the response. But what if we had an image that was actually many images? Consider a GIF. All right, so what I'm going to do here, so I've got this little spinning world GIF. I'm going to go into Chrome Tools, and I'm going to pretend to throttle my connection down to 300 kbps, and we'll refresh this. And what happens is quite interesting. It loads very slowly, but it actually is trying to render as many frames. It's trying to show me a frame as frequently as possible. It's like, okay, I got another one. Wait, I got another one. Here you go. It's not waiting for the whole GIF. It's showing me each frame as it comes in real time, and is rendering it as quickly as possible. So to take things back to that paradigm, or this diagram model, we've got a foo.gif request coming out from this IMG tag, and the server says, okay, well, here's your first frame, and the browser renders it right away. And then at some point in the future, don't know when, it could be a minute, it could be 2 minutes, it could be a second, whatever, it sends another frame. And then whenever it gets that frame, the browser says, okay, the browser doesn't know the difference between a server withholding frames versus a server that's just slow. So every time it gets a frame, it re-renders it. So this means that GIFs are data streams. We can use a GIF to render information in real time. We can use a data push model where the server is pushing these frames and the client is doing literally nothing. It's just, I mean, it's rendering the image, but the user is not like refreshing the page. It's just pushing new frames to this GIF. And the cool thing is the frame I just showed you, the idea was it had a complete GIF, but suppose it didn't. Suppose it was a security camera or a video game or something, and we're just pushing out whatever, whenever we want. So we can send anything using this data channel. So that's cool. So I made a little multiplayer roguelike. So I'm going to refresh this page. And I think I'm the little red guy. Yeah, I'm the red guy here. So I'm going to start moving. And then I'm actually going to go on my phone and move this blue guy here. Oh, he's not moving. There we go. So my red guy is moving. This blue guy, they're racing. I'm going to come down and see if I can push this boulder. No, I missed. But you can see the page is not refreshing. It's refreshing when I click links because we're doing that link thing where we go to the server and then come back. But doing this thing, telling him just like, go west, he can just go west and he's just going, and I can watch myself do that and I can watch other people do that. And I see somebody else has perhaps noted the URL and has jumped in. Anyway, so this is this model in practice. Okay, so I know what you are, of course, wondering, which is, you're saying, Andrew, it can do anything. Can it run Doom? Of course it can run Doom. So here we have AO3 again, and I'm going to hop in here, pull up this menu, enter, okay, make a new game. So I'm playing Doom. I don't want to play. I want to play the easiest mode. Absolutely. So here we go. We're playing Doom. So we can go forward. Let's run into this pit. Oh my God. Oh, geez. Oh, there's monsters in here. I'm going to click the start shooting button. So there we go. I'm shooting now. I'm shooting. Oh, geez. So anyway, you can see I'm definitely playing Doom. It's rendering stuff as I died. Who could have foreseen that? By the way, this is playing at about 4 frames per second because I have a real cut rate server that has a so-so connection. But you could stream it at whatever bandwidth you can tolerate streaming these GIFs. All right. So last couple notes in the few seconds I have left. For further reading, I use GIFs here, but modern browsers, I think, support this other thing called multi-part X mix replace that lets you do the same thing with other image types. You could actually stream a sequence of PNGs instead of using a GIF. You can say, like, it's not a PNG, it's like a channel for pushing PNGs. That it's exactly the same as what I showed you, but you can get better image quality than a GIF. So that's something to investigate. And so I wanted to embed interactivity into somebody else's static web page, like the AO3 thing or the Stack Exchange profile. But you can also do this same thing of like, oh, the GIF isn't finished yet for an entire web page. You can be like, oh, the web page isn't finished yet. So there's this other guy, Kevin, who has made a CSS only chat. So definitely check that out. It's pretty cool. I discovered that while I was researching for this talk. So I used A-links, but anything that sends an HTTP request can work. And background image CSS is cool because it's like if an element appears on demand due to like other stuff happening on the page, then it will only pull the background image kind of when the time is right. So you can use that as a signaling mechanism to the server. And there's like anything else would work too. Like honestly, requesting the image itself. That's like how a hit counter works. You request an image and then you increment a count. And that's it. Here's all the links. So for all of you, looking at the live stream later, you can pause this and get all of these things. All right. Thanks so much.
Wow. That was super cool.
Yeah, I love that Andrew asked the important question, which is, can I do Doom in this thing?
Yeah.
And yeah, of course. That should be the first thing you should ask yourself whenever you discover a new way of doing things. Can Doom
Does it run Doom? I believe Andrew also said that he was going to drop the link to some of this stuff in the chat. So keep an eye out for that if you are a ticket holder and are in our Discord. Yeah, gosh. We also had some people note that there were some Google Docs, for example, used that technique at one point to hold a connection open, which seems that like that's great. Like I don't know, just the internet. It's held together with duct tape, right? Like
Yeah.
duct tape and GIFs, I guess, is actually what we
Or
can say now.
GIFs.
Yeah, or GIFs. Yeah. Upvote for GIF, retweet for GIF. Let's move on then to Wade Minter's talk, building weird things with. There are two withs here. Sorry, I just got thrown off because the word with is repeated, but I don't think it's supposed to be. I think this is a typo. So I'm going to start over. Next up is Wade Minter, and the talk name is Building Weird Things with the National Hockey League Using Ruby.
Hi, everybody. My name is Wade Minter, and I'm here to present Building Weird Things with the National Hockey League Using Ruby. Now, in the words of Admiral James Stockdale, who am I? Why am I here? Well, by day, I am a product principal at Dual Boot Partners. I'm based in Raleigh, North Carolina. Prior to that, I was part of the founding team at sports tech company TeamSnap, which just got acquired, head of engineering at places like AdWorks and WeaveUp, and custom communications, a product manager at NBC Sports Engine. My background is in system administration, DevOps, but I also picked up Ruby development back about 15 years ago. But that's what I do during the day. But by night, I am the arena public address announcer for the National Hockey League's Carolina Hurricanes, meaning I sit ringside 41 nights a year calling out goals, penalties, and otherwise entertaining the crowd.
As part of Hockey Fights Cancer Night presented by UNC Rex Healthcare, we have provided fans and staff the opportunity to share who they fight for in the battle against cancer. At this time, we ask all in attendance to raise your card high and show everyone who you fight for.
Line. He lays it back to Wesley. To the outside he goes. Out in front. They score! What a play! Wade Minter hands it. He finds his line mate Catalano. The Godfather puts one in, but Minter off the bench and making saves.
As a multidisciplinarian, I've often thought, how can I combine these two parts of my life? On the one hand, I'm a tech engineer. On the other hand, I'm an NHL public address announcer. What could possibly bring these two things together? And the answer, of course, is pointless software. In my bopping around the internet, I soon discovered that there is an undocumented, yet very rich, National Hockey League game API that provides play-by-play down to a very minute level and gives you all the information you need about an ongoing game. As I looked at this API, I had a couple of different ideas of things that I could do with it, and that's what I'm going to talk about today. Two very pointless projects that I built with Ruby on top of the NHL API. Now, the first project I'm going to talk about is one that I call Tesla Puck. It's interesting because my car has an API as a Tesla, and my league has an API as the NHL. Now, Tesla has an also undocumented API, but one that's been reverse engineered. There's a Ruby gem on GitHub by Tim Dorr called Tesla API. That's what I use to talk to the car. Basically, if you can do it inside of the mobile app, you'll be able to do it inside of the Tesla API Ruby gem. It can talk to your car, it can start it up, get data, send actions, all those things that you can do inside of the Tesla mobile app. Now, the NHL's undocumented API is called StatsWeb. It provides information about schedule, teams, ongoing games, live data feeds, where if you refresh it, it's actually a really nicely documented REST API. And I use the StatsWeb API to determine what's going on in a game. Now, between the two of those, I had an idea. What if I could use the NHL API to determine when a game is over, a home game specifically, because my car is parked at the arena. And hockey takes place in the winter most often. I don't like walking through the cold to a cold car. What if Ruby could tell my car, hey, the game's over. Let's turn on your air conditioning or heating, depending on what time of the year it is. and set your car for home. That way, when you walk across the parking lot after dropping all of your stuff off, you'll be able to get into a nice warmed car and just drive on home. So that's what I did. Now, in the code, you can see several things we'll talk about here that makes it really fun. Now, as you can see here in the code, it's a pretty simple Ruby project. There are basically 3 classes: a sidekick worker, a model for the Tesla, and a model for the schedule. So I have a cron job that kicks off every day, and it starts up the worker. The worker will then check on a few things. It will see, is there a game scheduled for today? If there's not, no need to do anything. Is it a home game? If it's not, my car's not going to be at the arena, no need to do anything. Is the game pending? If so, check again later. Is the game in progress? Aha, so the game's going on, so we're going to check back about every 5 minutes to see if the game has gone final. If the game has gone final, it does a few things. It wakes up the car, and that can take a couple of tries. If my car is parked at the arena, or within about a mile, it will proceed. And then if the team won, it celebrates. That's right, I made my car celebrate. It honks the horn and flashes the lights in celebration if the Canes won the game. Otherwise, it prepares the car to leave, and that happens over here in the Tesla model. Celebration honks the horn and flashes the lights 3 times. Prepare to leave, starts the air conditioning to whatever it has been set to, and sets the navigation to my home address. All of this is powered by an inf file right here, easily configurable, runs in Docker. So if you go to NHL games and you have a Tesla, this is something you can use. I shudder to think how many people I've scared over the last couple years as they've been walking through the parking lot and all of a sudden my car starts freaking out with horns and lights because the Canes just won. My second project is called RoboGoal. Now this has a little explanation behind it. On Twitter for the past several years, I've been doing a thing called road goal calls, where if the team is on the road and a Canes player scores, I'll get on Twitter and record a video of myself from my living room announcing the goal just like I would at the arena. And it's become a fun little bit among Hurricanes fans. Everyone looks forward to it on Twitter.
Carolina Hurricanes goal! His 6th of the season, scored by number 88, Martin Necas. Assisted by number 20, Sebastian Aho.
But there are occasionally times when I can't do that. I've got a hockey game that I'm playing in, an improv show, some sort of scheduling conflict that prevents me from doing the road goal calls, and it makes people sad. They miss it. I had an idea, though. There is the NHL API. It's got information about every play that's happening in the game. What if I could write myself a script to obsolete myself and do the road goal calls for me? That's where RoboGoal comes in. So as you can see, another fairly simple Ruby project. There is a scheduler that checks if there's a game today. If so, it enqueues the game stream. Now the game stream checks the live feed for goal plays. If Carolina has scored a goal, it will kick off a worker to process the video file. If not, it just requeues itself for another minute until the game is final. Now the worker is where the magic happens. It checks the stat feed for that particular game. It starts building a tweet, and it starts concatenating a bunch of audio files. As you can see, I've got a bunch of different calls for however many goals the players scored. I've got all of the different player names on the team. I've got different times. This was the most complex. And it uses SOX and FFmpeg to concatenate these things together along with a photo and to build a video file with an audio track that sounds a little something like this. Carolina Hurricanes goal! His 17th of the season, Scored on the power play by number 21, Nino Niederreiter. Assisted by number 22, Brett Pesci. Assisted by number 88, Martin Natchez. Time of the goal, 11:09. Second period. Now, is this software pointless? Absolutely. Was it tremendously fun to write? Also, absolutely. I had a great time melding my knowledge of Ruby with some fun data that's available and created something that I can enjoy. And really, that's what software is all about. If you build something that you love, you'll be happy and you'll make the world a little bit better place. So if you've got crazy ideas in your head, go ahead and build that software because you can take it to the bank. It won't be any dumber than this. Thanks for watching. Let's go Canes.
Good good ending there.
I love the energy, though.
Yeah.
DC was pretty shocked when my laptop started screaming and
Honk.
woke up very irritated. But yeah, that's awesome.
I love there's like very obvious like screen like the phone jumped when the car honked.
Yeah.
Oh my gosh. All right. Somebody pointed out to me on the chat that I've not been reading the bios of the speakers. And somebody else in the chat pointed out that they are in the script, but I can't find them. So I'm going to go load that up real quick and then find who's talking next. Oh my gosh, I have too many tabs open. And then, nope, I've messed up.
Okay, I have
Take
them
it away.
at hand. I can read.
Please do.
Okay, I'm gonna start with Andrew, who was first, and we missed it. Sorry, Andrew. If you've enjoyed Andrew's talk already, Andrew is a programmer who thinks a lot about security. He enjoys copyright law, federated services, and surprising solutions. As we could see, a surprising solution for playing Doom in GIFs. And Wade, who was just presenting, is a product principal at Dual Boot Partners, where he helps companies build great software. He was a member of the founding team at TeamSnap and headed up engineering at AdWorks, WeaveUp, and Custom Communications. He's also the arena public address announcer for the NHL's Carolina Hurricanes, a 20-plus-year improv performer, ring announcer for Professional Wrestling Federation, and Beer League ice hockey player goalie. He leads a weird life. I would agree with that.
Do you, since you're on a roll, do
Yes.
you want to introduce Robin?
Yes, our next speaker is Robin Spear. Her talk is, and sorry if I mess up the title, Mojibake. What the heck happened to these strings? What the heck happened to these strings?
That was
Sorry,
pretty
I
good because
supposed to
there's
pronounce it.
like unpronounceable characters in the name of this
Yeah.
talk. So
I mean, I'm used to unpronounceable characters. Robin is the developer of the multilingual knowledge graph ConceptNet, as well as several open source projects, including FTFY. A decade ago, she co-founded an NLP startup called Luminoso. Now, in her increased free time, she plays and modifies randomizers for retro video games. So,
Hi, I'm Robin Spear, and I'm going to be talking about how text breaks and how to fix it. So mojibake is the phenomenon when text ends up with the wrong Unicode characters in it due to an encoding mistake. And FTFY is a Python library that I developed over several years that understands in several cases how to fix these characters. So here's an example of what FTFY can do. It can take this mess and understand it as the French sentence that it was actually supposed to be, even though one of the words got extremely mangled. So let me introduce the mascot of FTFY, who is this little guy. This actually comes from this text that I found in the wild. And if you use FTFY to decode the multiple layers of mistakes that happen to this text, you can see the face that it was actually intended to be. And I like this guy because he's giving you a really you-can-do-it face. And it's the result of actually decoding some very messed up text. So let's go back to a simpler time when 1 byte represented 1 character. And this meant that there were at most 256 possible characters of text that you could represent on any given computer. And let's hack up some quick Python code that's going to show us tables of these characters. So a very straightforward character table is called ASCII. And these are 128 of these characters that we agreed on back in the 60s, and we can all agree on what byte corresponds to what character as long as it's one of the 128 characters in ASCII. And if it's one of the other bytes, then ASCII just doesn't say what it means. And this is a set of characters that works out pretty well, especially if you're a monolingual American. But there are many more things that you're going to do with text, and eventually you're going to realize that you need more characters than that, and especially if you're speaking other languages. So people started talking about the idea of extended ASCII, where we could use the other 128 bytes as characters also. And extended ASCII just means whatever my computer does with the other bytes. And it's going to differ from one computer to another, because it could be from a different country, so using a different character set, it could be running a different OS. And this is how Mojibake started. Let's take a look at these different extensions of ASCII, which are called code pages. So a code page you might be familiar with is Windows 1252, which would be used on English copies of Windows. Wait, I missed one. Here's Latin 1. This is a very straightforward code page because it's the first 256 characters of Unicode. And so it's very easy to implement by accident. If you don't really know about Unicode and you just replace every byte with the Unicode character with the same number, you end up getting Latin 1. And I labeled 2 of these rows as Here Be Dragons because those are 2 rows of the table that are full of control characters that nobody ever agreed on what they do, even when it became an ISO standard. And Windows 1252 fills in those rows with more punctuation characters, curly quotes, bullets, things that ended up being useful on Windows. But that's only on Windows. If you were looking at the 256 characters you have available in DOS, then you would end up with this different character set, which has all these line art characters in it, and yet another character set if you're using Mac OS Classic. And if, for example, you had a Russian version of Windows, then you have this character set, which has the Cyrillic alphabet in it, which is, of course, very important for writing in Russian. So clearly the situation is unsustainable, and Unicode came along and said, hey, it turns out there are way more than 256 characters. But Unicode was originally hard to use because it wasn't compatible with ASCII. And UTF-8 is a great idea, which is, what if we leave ASCII alone, and instead of using those 128 other bytes as just 128 more characters, what if we use them as a variable length encoding for the entire rest of Unicode? And there are some really great ideas in UTF-8, such as not overlapping with ASCII ever, and also being self-synchronizing. It's got patterns in its bytes that tell you where each character begins and ends. And so if you jump into the middle of a UTF-8 string, you can tell where the start and end of each character is in the bytes. And so everybody adopted these great ideas and used UTF-8, right? Well, no, of course, it's not that simple, especially because Microsoft had just done all that work to make Windows support Unicode, and all of their APIs use UTF-16, which is more difficult to use. And so this provides more opportunities for Mojibake. So let's have some more code that's going to show us the sequence of bytes that represent each character in UTF-8. So if you take this name, L'Hôpital, we can look at it in UTF-8, and the simple letters that are ASCII letters are single bytes, but this curly quote turns into 3 bytes, and the O with an accent on it turns into 2 bytes. And so if you've got text that's in UTF-8, you can encode it as bytes, and somebody else can decode it as UTF-8 and get the same text. But if they decode it as a different character set, then they're going to end up with something like this, with a bunch of miscellaneous symbols in it that weren't intended, and that's Mojibake. And any mistake that you can make with a computer can also be repeated. So you end up with these pileups of Mojibake where the same encoding and decoding mistakes get iterated. And the fortunate thing here is because of the self-synchronizing nature of UTF-8, we can recognize the patterns that it leaves behind, because the patterns of bytes that make up UTF-8 show up as distinct patterns of characters in the Mojibake. So this second string here, with all of the square root signs and not signs in it, is sending us a huge signal that, like, hey, this is actually supposed to be UTF-8, but it came out in Mac OS Roman. And when we see a pattern like that, we encode as whatever the other encoding was and decode it as UTF-8 and presumably get out what the text was expected to be. So we can take that example and we can decode it, encode it as Mac Roman, decode it as UTF-8, and get this, which is still Mojibake, because it turns out that we need to do that again, and we need to do it again. And after decoding 3 layers of Mojibake, we get the text that was intended. But this is a job that the computer can do for us. So here's some code to use FTFY and format its output nicely. And we can put the text into FTFY. And so the first example here, it shows us that what you need to do with this text is encode it as Mac Roman and decode it as UTF-8 3 times. In this other example, it turns out that all of this Mojibake was just 1 apostrophe, and you need to encode it as something like Windows 1252 and decode it as UTF-8 3 times, and maybe even uncurl the curly quote at the end if you want. And this is an example I love because they said, I just figured out how to tweet emojis. And then they hadn't quite figured out how to tweet emojis because they're tweeting through something that used a broken implementation of UTF-8 and also somehow came out as Latin 1 instead. But if we recognize that, we can figure out what the emoji were actually intended to be. Now, we can't just apply this to every string that looks like it could have been UTF-8, because we don't want to have false positives. There are combinations of symbols that could have been UTF-8, but are actually what you meant in the text. So you could be writing in capital letters with accents next to punctuation, or you could actually be talking about the square root of pi, and we don't want to replace every instance of one of these with a different character. You would get examples that are wrong, like these down here at the bottom of the screen. So it's important for Mojibake to have a regular expression that can detect when something is likely to be Mojibake. And so we call this the badness metric. And so it looks for things like these improbable combinations with accented letters next to particular currency signs, or maybe unpopular punctuation like the Pilcrow sign next to another character that comes from one of these character sets. And with this big regular expression, we can recognize patterns like this. So in this string, 3 out of 4 of the instances of Mojibake match the regular expression, and they all have the same explanation for what went wrong with them, and we can use that to just fix the entire string. So this is a heuristic that I've been hand tuning for several years, and people have asked me, well, you know machine learning, why doesn't FTFY use machine learning? And I don't think I'd be able to keep the rate of false positives this low using machine learning. It's very hard to explain to machine learning the idea of an error rate of once in several gigabytes of multilingual text. And also, in my experience with language models, they have a tendency to kind of homogenize text to make it say what they expect it says instead of what it actually says. And I don't want to do that. I don't want to cause more problems using FTFY. And so that's why I tune it by hand instead of using machine learning. But let's talk about some of the root causes of Mojibake. And I identify 3 causes that I encounter over and over. One of them is Microsoft Excel. The second one in general is programming language APIs that confuse you about how to use Unicode and let you mix up bytes and text. And the third one that I run into a surprising amount is an outdated heuristic called Chardet. Let's take a look at that. So Chardet originated as part of Netscape Navigator in 1998. And in the 90s, because there were all these different code pages that people were sending around text in, you needed to be able to guess, based on completely unlabeled bytes, what encoding it was in. The problem is that the assumptions come from the 90s, and these assumptions aren't necessarily true anymore. Chardet doesn't know that the correct answer to what encoding is this is usually UTF-8, and it's never seen an emoji. So if you show it the bytes that make up an emoji, it thinks that there's some kind of Turkish. But the biggest problem is Microsoft Excel, because there have been so many different ways to export supposedly plain text CSVs from Microsoft Excel over the many decades of its existence, and Microsoft never breaks backwards compatibility with anything. So if you're trying to export a CSV, you have all of these options for how you could export text from Excel. And if you want to use UTF-8, every single one of these options is wrong, even the one that says Unicode text. And I know that you might have to use Excel sometimes, but if you want to make a CSV file, to have comma-separated plain text, I strongly recommend that you use LibreOffice or Google Spreadsheets instead, because they can handle UTF-8. In general, I've got a recommendation for how to avoid mojibake being produced by your code. Because if you use English a lot, you might go for a long time without noticing mojibake because all the ASCII characters are still right. But the good news is emoji are everywhere, and people expect them to work, and they are a really good test of your Unicode. So my recommendation is use lots of emoji. Put them in your code, your UIs. Definitely put them in your test cases, and make sure that they come out right. And it won't even look weird because people use emoji all the time anyway. This is similar to the way web frameworks used to put extra parameters in the URL, like snowman equals this picture of a snowman, because then the web framework could make sure that the browser had to use UTF-8 and detect if it came out wrong. And that's what I've got to say right now. Here is some extra information about FTFY and about myself. Thank you.
Thank you. Oh, excuse me. Oh, thank you. Wow.
I love the solution of using more emoji everywhere. I think that should just be a standard. Like, you should have at least one emoji in every function name. I think that would be good. Would make us happier as programmers.
We're going to require one non-ASCII character in every talk name.
Yes.
Yeah, you need to have an exclamation point and a non-ASCII character just to really raise the bar.
Yeah, and as an immigrant, as someone who doesn't have any Polish diacritical marks in my name, I'm happy about that every day living in Canada, because it would be impossible. Like, my friends have trouble doing basically anything here, like getting a phone number, right? Because they are not able to register with their names. So I think it's super important. Thank you for talking about this.
I missed who it was, but in the chat somebody said, that they raised the issue that their name turned out as Mojibake. And the devs responded by just making the form not accept non-Latin names, which is just...
That is not a solution. Anything.
Oh, well. That's the easy way out, not the correct way. Just for future reference. Okay. Let's go to our last talk of the day. How about I'll read the title and you'll read the bio?
Yes.
All right. So up next is Wilkie talking about save icons in real life, a joyous look at the floppy disk.
Wilkie is a systems programmer, wannabe archivist, and not a proper noun. I do research and development of federated systems for software preservation and archival focused on scientific software and replicability.
Okay, hello. Here we go. First lesson for you about the floppy disks is that everyone loves them. Dogs love them, cats love them, and of course, Wilkies love them. I have thousands of them. I enjoy archiving them, preserving them. I think we don't think about how to preserve floppy disks enough and exactly how to do it, so I'd like to change that. But in the meantime, I'm going to share my love of the floppy disk and kind of how it works and what's interesting about it. First thing is, just like human beings, it comes with a variety of beautiful shapes and sizes. The 3.5-inch disk is probably what you mostly think of about a floppy disk, but it comes in a 5 1/4 inch. And of course, the big chonk himself, the 8-inch disk, a little bit big on my taste, I have no idea, but for the original disk was 8 inches. Just old lordy common size, if you ever seen one. So what's interesting about these, they all work the same way. They're all different sizes, but they all effectively are the same technology, which I think is really cool. History lesson here. This computer, just like me, is from 1987. It's $1,200, and it has no hard drive because that would be too expensive. Hard drive would require a card, and the drive itself, you're talking another $1,000. And the thing is, it has embossed 2 floppy drives instead. Now, they're both 5 1/4 inch. You put your software, you run it from one, you put a blank in the other to save it. And that was so common for a stretch of time that to this day, it is our visual metaphor for saving. That's our save icon for you, because that's literally all you would have to save on. So interesting. This save icon is from PowerPoint, and I probably stared at this thing for months at a time. I'm sick of it. And even though we had that era where floppy disks were basically the exclusive way we shared information, they became obsolete quite quickly. And it's pretty easy to see why. Doom came on 4 disks. Doom 2 came on 5. Windows 3.1 came on 6. Windows 95, 13. Office had the option of coming on 24 or even 30 floppy disks. And yet, all these disks versus one CD, who would win? The CD would win handily. 1.5 megabyte floppy disks here. A CD can hold over 500 of them. No contest. As soon as people had this, there is no more floppy disk. Goodbye. Speaking of being doomed, make sure you check out Phil and Kimmy's talks, by the way. Just want to plug them. Doom's been referenced a lot here, and I am so happy about it. So what's cool about floppy disks, of course, is how it actually stores data. So how do you get binary data onto your disk here? Well, the answer is simple. You use magnets. How does that work? Well, first let's talk about the physical nature of a disk. Now, the 3.5 inch is a rigid disk. It's got a plastic shell, and it's still floppy because the inside, right, the flexible material here is a magnetic material. It flops around. And it's usually some sort of ferrous thing, like iron oxide, cobalt, barium, ferrite. Doesn't really matter, as long as it keeps a magnetic field, right? This is going to be subdivided into cylindrical regions called tracks, and each of those are going to be divided into sectors. The disk drive itself, it has a magnetic head, and its only responsibility mechanically is to seek to the right sector. And it does that by rotating the disk, of course, and selecting the track by a lateral motion with a little motor on it. That moves the magnetic head up and down. Now, the thing about that I want to appreciate is the sound that it makes. I think I could go to sleep listening to the sound of floppy disks, floppy drives, because they are just they have this mechanical sound which just never gets old. I miss it, honestly. All right, so digging down into this, we can see how we would represent the magnetic information. Basically, the disks are magnetic fields, and they're going to represent pockets of information by the change in polarity. So if we can represent this by a bunch of bar magnets lined up, when the polarity changes, that's a 1, and when it stays the same, that's a 0. You can imagine how this would work. You're holding a magnet in your hand. You close your eyes, and you're hovering over these magnets. And whenever you feel the attraction, repulsion, whenever that changes, that's going to be a 1 to you. And whenever you don't sense anything, that's a 0. And in the ideal world, this is enough. We have a byte of information, 8 bits. That's great. Except we live in this thing called reality, and it never likes us to have nice things, which is a shame, really. So there's a problem with this. And the problem is, if I asked you to snap your fingers every second, and then I ask somebody else, you both do it a different way, because you have a different internal understanding of how long a second is. That's true here. Writing a disk on one drive does not necessarily transfer to another very well. Basically, long stretches of zeros are a problem, because if we're closing our eyes and hovering over them, we don't sense any change. And for a length of time, how many zeros, how many magnets underneath was that? 2, 3, 4, 5? It's not apparent. So how do we solve that? Well, the same way I would solve it if you and I were snapping our fingers and we wanted to synchronize. We keep some sort of clock, a metronome, a tapping foot, right? Something like some conductor here is in the background, making sure that we play the notes at the same time. So what we can do is very simple. We can make sure there's always a polarity change, some attraction repulsion change. We can tell with our magnet, and we can have that exist at a regular rate. So we always sense it within the data. So we can take our data, 0010 is our data that we're encoding, and we'll insert a 1 in between by switching the polarity underneath. And now we basically can sense that beat, the tapping of our foot. Whenever we sense a delay, that's a 0 and a 1 otherwise. So we ensure there's at least 1 change of magnetism per every bit. This is called frequency modulation encoding. And the array-inch chonkers here, that's what they did. And that was pretty good. It's naive, but it works. If we look at the wave produced, we see a square wave here where every vertical line is a 1. That's the thing we can sense. What's our problem is the horizontal line. If that gets too long, then we start to lose track of what it is. What's really, really fascinating to me is there's dozens of ways to do this. With the same exact technology here, there are dozens of ways to represent information. That's one, our tapping of the foot. Another thing we can think about is allowing our clock or our tapping of our foot to rest. Let it be a 0. Because the only thing we're really worried about is interrupting series of zeros. We can just insert a 1 in there with our clock bit whenever we sense a series of zeros. So if we have 2 zeros that are in our data, we put a 1 in between. Otherwise, we can have the clock be a 0. We don't have to tap our foot because the data is doing that for us. There's a note being played that we can synchronize on. And this simple change of just putting the 1 in between zeros, called modified FM encoding, it ensures that at most 1 polarity changes per bit. And we get this curve. This is the same exact data as before, but our curve is a lot smoother, right? There's a lot less vertical lines. The less, the better, honestly. So this is just a very simple change. And we can see the different waves here side by side. And we have, a simpler wave. Now, what you might be thinking is what improvement was actually made. We have the same amount of information here. It's the same data. It looks like we haven't really, maybe we were more clever, but we didn't actually solve a problem. It's easier if we look at the worst case, which is encoding all 1s in both. And with our tapping foot at the top, we have a very chaotic square wave here because we're basically changing polarity constantly. So we have this really, really rigid square wave here. It's very compact. In our modified encoding, though, we actually allow that 0 there. We can never have 2 1s in a row. So we never get that strict square wave. In fact, it's always our worst case. It's going to be just twice as efficient. And the thing about this is we have to change our brain a little bit. If we can handle the top square wave, but we never have it, what can we do? One of 2 things this enables. We can spin our disk twice as fast, or we can store twice as much stuff in the same space just from our simple change, which is why we call this single versus double density. I just find this really fascinating. It's a very cool change. It's bizarre to me that you can make that small little change in how it works and have drastic differences. You can fit twice as much stuff on this thing. That's really fascinating. And I want to end on visualization of the flux. So the flux visualization here. We're seeing the magnetic field across the entire disk. We're zooming out, and we see all 3 of these different OSs do different things on their floppy disk. They all have different strategies for how they store information. I find that fascinating. There's no best or worst thing here, but they all do it a different way, and it makes you think, right? If you can store the flux in different patterns like this, why can't you store it in a strategic way to paint whatever picture you want? Can I hide information on this? Absolutely. I can put a picture of this, my password here. I give you this floppy disk. It's not going to read on a normal machine. Hook it up to an oscilloscope, though, and you'll see this image. A little bit of stenography. Make sure you check out William's talk on stenography later on. And if you can do that, then you can put any image you want on it. I think the Bang Bang Con logo is a perfect opportunity to be used here. And now we have a little bit of art. I think this is great. Nothing is obsolete if you can make art out of it, right? Maybe that'll be true about me someday. But I think this is fascinating. I hope this inspires you to look at these old technologies a different way as well. If you make art with Ben's program here, thank you, Ben. Please send it to me. Please send me all your floppy disks. And basically, thank you for putting up with me. All right, floppy disks in chat. Thanks.
Floppy disks in chat. That's super cool. I didn't know any of that, and I'm not sure I entirely caught how the FM thing worked, but I will be I'm looking forward to rewatching that during the sync watch.
That's what rewatching is for.
Hoping it will sink in the second time. Not that was bad. I think that was amazing.
Yeah, that was a very good explanation, but it's a lot to hold in your head when you're learning for the first time. I think it was awesome.
Exactly. I've been looking. When I was very young, I wrote some Word docs. I don't even know if Word was around then. and I saved them on this floppy disk, and I've been like looking for it since then, and I have not found it, and it probably doesn't exist anymore. But my parents probably were like, whatever, old floppy, throw it out.
Yeah, my grandma, she's a programmer too, and she used to bring those huge floppy disks, the ones that are actually flopping around. Yeah. And I remember being very proud of saving stuff on it, and she still has them. I don't think they work anymore though, but she still has them.
That's why Wilkie's work is so important.
Yes.
To archive these beautiful technologies that are slowly degrading. I'm sorry, I've got something stuck in my throat. Let me mute.
No worries. So this was our last talk for today. And the next thing coming up is a hallway track. So if you're on Discord, if you're a ticket holder, you can go to Skittish and pick that cute little avatar, walk around, meet some people, and just enjoy the time before our next day of the conference. And we would love to thank all the speakers that we had today: Andrew, Wade, Robin, and Wilkie. It was awesome to have you, and we will have their talks again tomorrow at the SyncWatch, which is, and let me get all the time zones so I don't mix anything up. The SyncWatch for today is going to be tomorrow at 11 a.m. Pacific, 2 p.m. Eastern, 7 p.m. British, 8 p.m. Central European, or 11:30 p.m. Indian Standard Time. So hopefully, if you didn't have a chance to watch it now, this SyncWatch will work for you tomorrow, and we will make sure that the captioning is there so that it's actually accessible and available for everyone.
Cindy, would you mind putting my shared screen up? I'd also just like to thank our sponsors again, Xander, Daily, our excellent tier sponsors, and then we also have our awesome sponsors, Wherewithal, Discourse, Full Story, 2 Sigma, Phasro, Mapbox, and Accelerated Tech. And thank you to all of our sponsors for making this possible and allowing us to provide things like captions, which will be here on the recording, and other just all of the other things that we do, like paying our speakers and providing the cool things that make Bang Bang Con.
Yep. And we would also love to see your experience of Bang Bang Con, even if you're not on Discord. If you want to tweet it out, and if you either mention Bang Bang Con, not BTS, not Bang Bang Con. I don't even remember those tags anymore. It's
like BTS TWT or something. We are the actual at Bang Bang Con.
Yes, that's us. So if you mention this is us, or you can use the hashtag virtual Bang Bang Con, which thankfully has not yet been taken over by the army. So we'll be able to see you tweeting at us. And if you want to tweet at us or our wonderful speakers, make sure to do that and thank them for being here.
And thank you all for being here. And for those of you with tickets, we will see you on Skittish.